we are going to start a new chapter, which is electromagnetic induction. In short, we can call it as EMI. Now, before going into the topic, you need to be very clear with the concept called as magnetic flux. Now, the definition goes like this. Magnetic flux is quantity of magnetic field line linked to a surface area. So, let's say we have magnetic field lines in a space. So, this is the direction of magnetic field line. Field lines are heading to my rightward direction. So, field lines are going in this way. Now, I am going to consider an area. So, you always know that area is a vector quantity, that is cross multiplication of length and breadth, and the direction of area will be perpendicular to both length and breadth. So, this is the direction of area. Now, when I am keeping my area in this way, we know that all the field lines will be linked with this area. Now, area makes an angle of 0 with the magnetic field line. See, magnetic field line is going in this direction, area is also in this direction, angle is 0. So, all the magnetic field lines are linked with this area. But at the same time, if I am keeping my area in this way, will there be a magnetic field linkage? No. In this case, direction of area is perpendicular to the field line. So, we got to know that higher the area, more amount of magnetic field will be linked. And higher the magnetic field intensity, again the number of the flux linkage or field linkage will be more. And not only magnetic field and area, but also cos theta, okay, or the angle in between. When the angle are 0, which means, see, when I am keeping in this way, where my field lines make an angle of 0 with area. In this case, maximum flux linkage or maximum magnetic field linkage, but when I am keeping in this way, 0 linkage. So, flux is proportional to B, higher the intensity, more field lines. For example, I have a north pole here, so field will be going in this direction. Okay, this will form a closed loop basically, but I am just writing in this way. Now, when I am keeping a small area here, it links all the magnetic field lines, right? But same area if I am keeping here, only 3. Now, if I am considering the same area here, only 2 field linkage will be there. So, higher the magnetic intensity, more is the flux linkage or field linkage. Either you can call it as flux. So, flux is nothing but field linkage. So, here the flux is more, less and very less. Now, higher the area, at the same time, if I am considering a higher area here, instead of areas in this way, if I am considering area in this way, more flux at this point. And at the same time, if you are keeping the area in this way here, then 0 is the linkage. So, we know that B and A and cos theta are the parameters that flux is dependent on. Okay, so this can be written as B dot A. We know that B and A are vectors. So, B dot A is nothing but BA cos theta. Now, let's say if you are having an irregular surface in this way, how to get magnetic flux at this point? Just draw area vector and get the net magnetic field at that point. Just multiply BA cos theta. How you will get the angle theta? In the angle made between A and B. So, for example, here if you want to get the magnetic flux, just take the tangent of the area. So, to the area, just draw a tangent, and perpendicular to the tangent will be the direction of area, and with that area, see what angle magnetic field is making. Then multiply BA cos theta. So, this is B1 A1 cos theta, B2 A2 cos theta, this is A2 and B2, this is B3 A3 cos theta. So, this is theta 3, theta 2, theta 1. Similarly, you can add all of them to get the total flux linkage with this surface. Okay, so this is a very important concept. Now, we will see unit and dimension of flux. So, we know from this equation that flux is equal to B into A. First, we will see unit. See, what is the unit of, see, B into A into cos theta. So, unit of flux is equal to unit of magnetic field into unit of area into unit of cos theta. But cos theta has no units, right? It's basically a ratio. What is cos theta? cos theta is adjacent divided by hypotenuse. So length divided by length, meter divided by meter. See, L1 divided by L2 is cos theta. So it is meter divided by meter, no units, no unit. And magnetic field, what intensity of magnetic field, what is the unit? Tesla. Area, what is the unit? Meter square. So flux can be measured with the unit of Tesla meter square, or this can be rewritten as Weber. So Weber and Tesla meter square is the same thing, but here in this thing we are going to get a new unit for Tesla. So Tesla is equal to, as per this equation, Weber by meter square, or Weber meter power minus 2. So magnetic flux can be measured as Tesla meter square or Weber. At the same time, magnetic field intensity can be measured as Tesla or Weber per meter square. So if the question is given and where the quantity is measured as Weber per meter square, you can understand that it is magnetic field measured. Okay. Now, what is the dimension? How to get the value of dimension? We have equation is flux is equal to B into A cos theta. Cos theta has no dimension because it's a ratio. Now dimension of flux is equal to dimension of magnetic field into dimension of area. Dimension of magnetic field as of now we don't remember, but area is length into breadth, it is meter square or L square. Now how to get the dimension of intensity of magnetic field? I can do it in this way. I know F is equal to ILB. So dimension of force is ml t power minus 2. Dimension of current is ampere. Dimension of L is length into dimension of B. Now from here I can get the dimension of B. What is that? L will cancel. This will be A will come here, and M A power minus 1 t power minus 2. A will come here, A power minus 1 t power minus 2. Yes, very nice. Now this magnetic field I will keep here. So this I am substituting here. So M A power minus 1 t power minus 2. So this will be M L square A power minus 1 t power minus 2. This is the dimension of flux. For competitive level examination you can expect questions like this. Even for CBSE you can expect questions as a 1 marker in the first 21 markers. Okay. Even for PUC it is important, but I have just specified it in this way. Okay. This is very, very important, and thank you.